warping space-time is something we see in the natural world all the time. So we see with GPS satellites. In fact, the GPS satellites right now, everybody has on their phone, oh, I'm going to see where I'm at today. Those clocks have to be calibrated and recalibrated, even though those cesium clocks on those satellites are exactly the same as the ones we have on the ground station. They have to constantly recalibrate. And the reason why is because the effects of Earth's gravity has on the space-time of those cesium clocks here on Earth relative to those cesium clocks that are on those platforms that are above Earth. In fact, the clocks that are above Earth compared to the ones on Earth are running slightly faster. Now, how is that possible if they're the exact same type of clocks? Well, that is because the effects of Earth's gravity, the closer you are to a massive object, the more space-time is warped. And we've seen that with Einstein's relativity. And it all boils down to E equals mc squared, basically. What we're talking about is lots of mass or lots of energy to warp space-time. The closer you get to a supermassive object like the sun, the greater that distortion occurs. In fact, when you get to a black hole, time is so distorted that time stands still. So we know, we've seen this, we've seen it with gravitational lensing. When we're looking at a far distant galaxy, we can see the effects gravity has on space-time. We can actually see it with our eyes. So we don't have to prove that. That is science fact, not science fiction. So the question is, technologically, how can we go ahead and manipulate that physics to our benefit? So now we can potentially warp space-time in a way that allows us to go from point A to point B a little faster.